I'm Jim. I work for Red Hat in the cloud team, and today we're going to talk a little bit about the benefits of creating automatic systems, but in the context of environments that are more common, say, in our market, Australia and New Zealand, not the big PaaS and SaaS providers, environments that are mixed, old and new, a mixture of maybe legacy applications, new modern applications, mixture of cloud, mixture of on-premise, right? Arguably a more difficult place to create automations and automatic systems. So let's get into it. I thought I might take a little stroll down memory lane and talk about how we got here. Really important to understand some of the attempts to create automatic systems in the past. We have tried some of the learnings from that and see where the market's going in this space and where we can learn from. So I guess I wanted to start with some of the key people and players. It's really about people in the end. We have the two groups that deliver software applications to end users, and it's the operations team on one side. Their job is to maintain the platforms and systems and applications and ensure the availability to end users, right? Quick show of hands, who has a IT operations type of role here in the room? Right, yeah. And on the other side, you've got sort of developers, right? And their job is to make changes, create new applications, to provide great end-user experience for those users that end up using those applications, right? Any developers here? Yeah, a few developers? Less than the operations team, so I can make fun of you lot. But check this out. When you pull out some keywords here, hopefully my Google Slides work. Ensuring as little change as possible, IT operations, and on the other hand, trying to introduce change as fast as possible in the environment, right? Diametrically opposed in sort of mindsets, but a common goal. The delivery, again, of software applications or services via software applications to end users. No wonder we don't get on, right? So what did it do? We created DEVOPS. DEVOPS was first coined almost 10 years ago, 2009, in Belgium at a conference called DevOps Camp or something like that. And it's been widely adopted in most organizations that I walk into and have chats with these days, right? We all know what it is. It's kind of like the direct reaction, response to the traditional way of working, develop here, handball over to operations to run, producing a very slow life cycle in terms of delivery. So practices, culture is huge here. The embracing of sort of agile methodologies, accepting failure as normal. You know all this. Implementing gradual change rather than big changes all at once, right? Leveraging tooling and automation. I want to call that one out. It's inherent in the way DevOps teams work. They want to be able to check in source code up into their repositories and have that automatically build, deploy, test, and eventually take it out to production, right? And really the goal is to deliver the highest quality applications faster than ever before, right? And it's come a long way. But did we just create another silo, okay? So what we find typically is that in environments, even the large environments, maybe 2 or 3 DevOps projects popped up. People swiped their credit cards, got some public cloud, yeah, and started to embrace DevOps practices, okay? And, we did, right? We actually created another silo. And we've got to look at why, yeah? And I'll try and explain some of the things that are going on. IT operations have some unique challenges, right? Things that, continue to change and evolve, but nonetheless, as I said earlier, that's, being able to support, integrate complex, diverse generations of applications, multiple management tools, different types of hardware, many applications, many operating processes, right? This is a challenge in its own right. We're asking operations to do this faster. Often, we say DevOps goes really fast. Operations, can't you move faster? You're slowing us down. You're not letting our business move as fast as we would like. Can you go faster? And then we're also seeing that their budgets are generally decreased, right? So we're saying, super complicated. Can you go faster? Can you do it with less? And no wonder when I go and speak to IT operations teams all over Australia and New Zealand, a common theme kind of emerges. And that's that they're not able to break that manual cycle of toil, right? Just keeping the lights on, systems operating, and not having enough time to do any sort of innovation, right? You know, it's 90% just keeping the lights on, 10% of the time innovating, if not less, in some organizations, okay? So IT operations has these challenges. They're not going to change overnight unless we change our ways. DevOps is starting to get to the challenge phase, right? Initial adoption, initial joy, speed of release, very exciting, but is it going to be able to scale, particularly in the large enterprise environments that I work in, right? And this is some of the reasons why. You know, you release that first big application, it's a great hit, it gets great accolades, and suddenly the security team starts to have a look and says, well, you know, we need to adhere to some security standards here. We're actually taking some risks. DevSecOps, you might have heard of that, yeah? Availability becomes more of a challenge. As you release an application, it becomes more mature, more functionality, more components to it, maybe more applications. It's really hard to maintain availability. You start to have, you know, traditional operations type challenges. What else we got here? We got complexity goes up, right? So we've got the application developed on its own in a particular business unit, and suddenly, you know, that's had great success, and suddenly we need to incorporate that with back-end systems from IT, like maybe it's the, you know, the accounting systems or other areas where data can be driven from or taken from, and you end up with more complexity, right? And this becomes harder and harder to operate, starts to slow down the DevOps team. And then suddenly you need to upgrade applications, do big upgrades, maybe even migrate. So for example, DevOps teams might have chosen a particular cloud in the early days. The organizations caught up and said, yes, we're going to go cloud or hybrid cloud, and we want everything to be on Azure or Google or AWS, and the application's been written for maybe another public cloud. And porting that, particularly if you've used sort of bespoke services from that public cloud, can be a major challenge, right? Let alone upgrading. So these DevOps teams are starting to get challenged in the way they want to scale. They want to go fast, they want to go bigger, but they're starting to face traditional IT challenges. Yes, so we are still evolving this. We've come a long way, right? IT operations is getting better and faster, but they still have complexity and challenges. DevOps teams have challenges with operations, and they're starting to merge a little closer than they ever have. And just as we get settled, what happens? It changes again. Site reliability engineering comes along, right? Everyone heard of SRE? Yeah, it's starting to become a common term in our language. More traditionally used in the PaaS and SaaS and the hyperscalers environment, was actually invented and coined by Google in 2003. So it's older than DevOps, by the way. And they had a need to do this because of the way they created applications. So it's basically another set of disciplines that incorporates, you know, the aspects of software engineering into typical IT operations challenges, right? And starts to address, you know, some of those DevOps operational challenges. But then some of the best practice can be borrowed into traditional IT operations. That's what we're going to talk about today. And then I also went on a job site, had a quick look today, Australia, New Zealand, site reliability engineering, hit search, 642 jobs were popped up. So maybe worth checking out. So here's a story from the field that I'm going to use to really be the guts of this presentation. It's a story from our own Red Hat site reliability engineering team, you know, a team that was created out of necessity because we got into the market of providing our customers a container platform as a service, right? PaaS environment where you can start to develop on our containers that are provided for you, ready to go. Or you can get your own segmented container platform in AWS that will manage for you, right? And as that scaled, this team needed to evolve from traditional IT operations team to a site reliability engineering team. And I want to share some of the learnings, and maybe you can take them away and think about how they might work in your environment. So here's the platform they support, okay? It's huge, right? Since 2013, when we launched these platforms, it runs 4 million applications, right? Across 80 plus clusters. That's thousands of virtual machines running hundreds of thousands of containers and pods, right? 12 regions, 750,000 developers have developed applications on this platform, yeah? It's attracted 6,000 plus new users of applications on that platform per week, right? And 2,000 applications being, on average, being introduced every day, right? So it's an amazingly complex and large platform. So put on your IT operations hats. I'll ask a question. From 0 to 50, how many people do you think are in the SRE team that manage this environment? Anyone going to throw up a guess? How many? 2? Whoa, that's crazy. Anyway, do we have a better answer? Another answer? 20. Better, yeah, look. It's actually 9 people, right? Currently 9 people managing an environment that does this, okay? It's pretty amazing to think about, yeah? So let's look at how they do it, okay? So, you know, there's a set of guiding principles that they sort of live by, yeah? Balancing the risk, I'm going to read out here, of unavailability with the goals of rapid innovation and ensuring end user happiness. Those 3 things are really, really hard to do, by the way. You know, it's the holy trinity of delivering an application. Reducing toil, that's a big one. Reducing toil, you know, manual, sort of hard labor, IT operating. And creating systems that are automatic, and we'll get into that a little bit more, and not just automated, balancing release velocity against safety, right? And this all really comes out from a book that's free. It's from Google, because they kind of invented this, and they share the knowledge, just like we share our code and knowledge as well with our customers. And it's a really good read. It's not too big. You can have a read and start to think about some of those good practices. But, you know, guiding principles are good. Let's look at some of the key 8 KPIs that they set themselves to deliver this at scale. Okay, some pretty interesting things here, right? So rather than manually fix, they want to manually fix, you know, 95% of the time, 90% of the time, and automate 5% or 10% of the time, they reverse it altogether. Their goal when they started was to say, we will only manually break fix 15% of the time and spend 85% of our time, right, looking for patterns so that we don't have to ever do that task again, right? And Narayan, who runs this team, says they're almost there after 4 or 5 years, right? They're up there towards the 80% mark, all right? That's the mindset change. Culture is absolutely everything here, right? And again, it's going to be hard in your environments, you know, culture change is super hard. So I'm not saying this is easy. It's about, you know, things like developers need skin in the game. That's kind of a DevOps practice, nothing new there. Concept of an error budget, right? So each team that's contributing change or pushing change into the environment gets an error budget. So you can make 5 big errors in this environment per 6 months, right? And if you make 5 big errors in that environment that hurt the environment and hurt the other people in the first week, you can never push to that for the next 6 months, okay? They can stop people pushing to the environment if they're creating errors. They get a concept of an error budget, all right? Think about that, okay? Different way of thinking needs to be adopted top down, right? Crazy, but this is what they do. This is exactly how they work at Google. This is how we work, right? And this is things that we need to start thinking about in our own environments. The other thing is, yes, it is easy to patch, configure, do things manually. It's probably easier, right? And it's a quick fix. But he says, resist, 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 right? And these guys resist to the point where they prevent SSH access into certain servers, right? So they can't do it at all, right? Pretty scary to think about that. Okay, there's some of the measures that they give themselves, and this is how they work and how they've evolved it, right? It doesn't happen overnight, yeah? Day 0, it's all about push button deployment. Bosco, before, if you came to the OpenStack session, that's a pretty complicated application to set up, involving many, many, many steps. But you want to be able to, from day 0, maybe a new project, think about pushing that out automatically, right? Okay, so you can create that test, that dev, that production environment as you want, as you need, okay, with the click of a button. But as we know, in IT operations, you know, creating the application is the easy part. You know, it's managing that application on a day-to-day when it gets really Under pressure, many applications are going on. Things are going to break. So what are you going to do, right? So again, it goes back to the discipline of resisting manual, doing more through automation, and you have to get there over time, no doubt. Configuring and tuning via automation. Monitoring is super important, to the point where in this environment, the application developers can add specific things about their application that operations teams can look for. Custom sort of monitoring for the applications are written, embedded within what they do. As they move forward, monitor and add auto heal. You've all got monitoring systems, probably many of them in your environment. And generally what happens is alert gets triggered, support level 1 gets called, right? And someone goes through a manual book to fix the bug, restore the service, closes the ticket in the middle of the night, generally speaking, or all throughout the day. That's an automatable function, right? Rather than that ticket, call a person. Why not try an automation to auto heal? If it's a simple fix, start simple. Might be adding more disks, whatever it may be in your environment, killing a process, restarting a service, basic stuff. No one gets called. If the problem persists, consult your support level 1 engineer, right? That's the kind of thinking here. Providing that visibility to the end users so they know that you're on the case, that you're looking at the environment. And finally, upgrading. I touched on that earlier. It can be a complex task, particularly if you've got a massive environment, 24/7 applications, right? What are you going to do? And particularly if you've got zero downtime kind of requirement, right? You can obviously do these concept of rolling upgrades when you've got many application servers, many things. You want to do one thing at a time, so automation's good for that. And then when it comes to doing major upgrades, it's all about these blue-green upgrades, they call them, setting up an environment that looks exactly like production in another cloud somewhere else, leaking that data across, switching the users at the right time across to that new environment, leaving both environments in sync for a while in case you have to roll back, right? And that can only be achieved, if you start from day 0 thinking about automation. Okay? So that's just some of the things that this team has managed to do by embracing some of these SRE principles, right? Okay? And just a summary of that. Pretty amazing what they do with such a small amount of team. And the growth curve on the OpenShift PaaS and managed service platforms is kind of like almost exponential for Red Hat. That team, he says, I'm going to grow by 2 more, and we're going to be able to scale out to that scale. Okay? So, today is really about, ideas worth sharing. So I'm going to pull out a few common themes that I see. They might not be right for everybody, but, some ideas that you can take back, maybe evolve and make better, right? So I'm going to share what I think you need to do to start to think about creating automatic systems in environments where you work, different kinds of environments. And the first big challenge is about having too much diversity in the environment. You've got so many applications, so many platforms, so many operating systems. How are you going to automate this when everything is unique? There's my snowflakes, by the way. Everything's a snowflake, right? If everything is unique, you can spend more time creating automation than doing it manually, right? So you've got to try and get down there and start to standardize your environment, make it look more homogeneous. The OpenShift guys have a good thing in that the platform they support is all OpenShift, right? Different versions of it, different environments, but it's all one system that looks pretty much the same, right? So you've got to think about how you can get from this diversity, or maybe buying different things for your environment and reducing that complexity. And we're at Red Hat conference, so I might as well talk a little bit about how Red Hat can help here. Obviously Linux. I've spoken to a bunch of customers. That sort of movement's already been done. I'm just showing it just as an example. We're moving away from proprietary Unix down to Linux, right? And Red Hat Enterprise Linux is a great platform to run critical applications on, okay? That's an easy one, but there's still some legacy out there that you might want to come in and help you get off. You know what? Developers want to develop on container platforms. Developers, is that true? Yeah? Yeah? All right. There's only 4 over there. But they're all nodding their heads. They want to develop modern applications on container platforms. And your business might ask you at some point, how are we going to create a container platform that's right for our particular environment, that doesn't provide lock, You know, if you go on a container platform, say on Google, and use all these fancy features, you'll never be able to get off there. Your application is written for that platform. They're going to love you forever, right? My point is, make good decisions about your organization. You may want to run some of that on-premise. You know, it makes a lot of sense to sweat the assets you have there and create a container platform on-premise. In fact, you might be able to save some money overall, because running in clouds can be pretty expensive for high workloads. My point here is, standardize on a container platform. Choose one that you can run on-premise, but then you can easily move to any one of those clouds that I just mentioned. Okay? That's just an idea. Think about your traditional virtual machines. It's not going to be all containers, as much as we love to say containers are the future, containers are everything, right, Richard? You're going to still run virtual machines, right? So choose a platform that will allow you to run traditional VMs. It doesn't have to be the most expensive hypervisor in the world to run a traditional VM, right? It's a commodity now. Think about that. You've got to unlock your budget, get onto something like maybe Stack, I don't know, just throwing it out there, where you can run traditional VM workloads alongside these containers and give your business cost savings, as well as platforms for these developers not to go to every cloud and every key feature that comes along, right? Just an idea. Software-defined is a great way of creating more homogeneous systems, right? We have a number of software-defined platforms. Ceph's one of them, yeah? Gloucester, et cetera. But, you know, think about that. Don't go and buy proprietary hardware with proprietary software embedded. You know, what we're trying to get to here is use the software, use open source software. It gives you the greatest choice, and just add cheap servers. What are the public cloud people doing? Exactly that, right? So think about standardizing as you go, right? You're not going to get this overnight, but new projects are a good idea. Go out there, find some budget, do some on an upgrade, maybe to standardize. All right? Okay, and it's a big topic, automation. I talk about automation a lot, right? But think about the SRE and DevOps teams. What are they doing? Inherent in their practices, from day 0 to day N, is automation is inherent in what they do. They can't do what they do without automation, right? So that's all right, they've got that solved, but it's harder in operations, right? So I spend more of my time talking to operations teams, because DevOps guys, the developers, they're too cool for school, they know what they're doing, right? You know, that's great. They're smart people, they're used to these new ways of work. I mean, old ways of developer working is new ways for IT operations, you know, source control, you know, automated testing, triggered out of a change, you know, branching, all that stuff is kind of maybe new to IT operations groups, right? But you've got to start to think that way. That's how you can move faster. But the argument here really is that automation becomes the common language of IT. The one thing that unites all these teams, that potentially can bring them all together and to get to that state where, you know, we're doing DevOps, but we're working together with IT operations. We've got SRE teams for special applications, but working together with IT operations, and automation becoming that common language across all those teams, right? It could be the one thing that unites us all. All right, so today, you know, really, as I wrap up, I want to offer something to all of you. Richard, Bosco, you might have heard earlier on if you attended the early sessions. Wilson over here, you know, we're all about helping our customers get the most of our products. You know, that's what the value that we add. Our software is available for free, right? But the value we add at Red Hat is to help you get it right for your enterprise through our support, through our knowledge sharing, you know. And what I do with IT operations teams in particular, I sit with them and we do workshops. And it's got nothing to do with technology, right? It's got to do with sitting down with you and trying to understand. And what we do is kind of bring people from different domains, different silos. We bring network people. We bring a database person potentially. We bring a systems admin from Windows, from Linux, from wherever that may be. Bring them together into a room. And we run a simple workshop. It's kind of fun. It goes for about 3 or 4 hours. We have some lunch. We have some laughs. We don't do the talking. The customers generally do the talking. And we look for things in their environment that we can automate, but not the most complex things, things that have really high business impact, business value, a low effort to implement, because that's a really good thing to start an automation journey on, yeah? So we can help teams, organizations, work through that, figure out a use case that makes sense, that the team buys in on, and then we can help you deliver that through a minimal viable product trial, yeah? get towers installed in your environment, get that use case going, show that to the people with the money, right? You're going to have to ask for budget and help you build the case for automation. So come and speak to us and at the booth, at some beers. We run these for a lot of customers. The most fun thing that I do, actually, when I see the lights flick and realize this is an easy one that we can start with and we can show real tangible ROI. So thank you for your time. Hope you enjoyed it, and hope you're enjoying the day. Thanks a lot.